So on which one?
Numbers 12 and 15.
Okay. The area of a sector with central angle pi over 3 and radius 12. So the full angle or the full circle would be pi r squared. But we don't want the full angle. We want pi over 3 out of 2 pi is the angle that we want. Or the part of the circle that we want. So let's see here. We got all kinds of fractions going on. Let's see. 144 pi. And then pi over 3 divided by 2 pi. That might be easier to write as pi over 3 times 1 over 2 pi. Keep it, change it, flip it. We should be able to do that. Pi's cancel. 144 pi over 6. But I bet 144 is divisible by 6. In fact, I bet it's 24. Because it's not 8, it's not 4, it's not 48. So it has to be 24. So yes, there are other formulas to do it. And the key may have used the other formulas. I think this formula is easier to... Tardy. I think that formula is easier to remember because it attaches so closely to the area of a circle formula. He was close and he was hurrying. That was like 3 minutes. 3 minutes late. Just trying to get some people extra tardies here. Other questions from that worksheet? So yes, the key, I guess, used a slightly different formula. I mean, it comes from the same thing. I just like using this one because it makes more sense to me. Haven? 13. The area of a sector with a central angle of 45. So again, I start with the area of the whole circle, and then I'll multiply it by whatever fraction I want to multiply it by. And the fraction would be, for this one, 45 out of 360. Because 360 is all the way around. So I'm glad we're doing 12 and 13 because one's in radians, one's in degrees. So pi times r squared is 36. 45 out of 360. Or, why don't we reduce the 36 and the 360? Because that would reduce to a 10 in the bottom. And then we could reduce both of those by 5. So 9 pi over 2. So that, in my mind, that's the same formula, pi r squared, and then multiplied by whatever fraction of the circle you want. Pi over 3 out of 2 pi. But if you're in degrees, it's 45 out of 360. (14 and 15 are kind of the same. Anything else? Arc length? I mean, that's the easier one, I guess. L equals r theta. Let's do that one. Then we'll move on. Except that for arc length, that angle has to be in radians. So 120, I'm not going to put 120 in there. I'm going to change that to, let's see, 2 pi over 3. So radius is 2 feet. Theta is 2 pi over 3. So that'd be 4 pi over 3 feet.
So where'd you get the 3? Just because all the answers are 3 there?
I got the 3 because 2 times 2 pi over 3 is 4 pi over 3.
No, the 3 for the bottom. Or is that part of the equation?
This 3
Yeah.
came from this 3, came from this 3, where I changed the angle in degrees to an angle in radians. Anything else from that I guess the rest was coterminal stuff, and that's not really that hard. Add or subtract 360, add or subtract 2 pi, as many times as you like.